Great to have you guys here, and thank you very much for joining the webinar. We have some customers who are really pushing the boundaries of what they used to do on their existing platforms, and they're moving into this new challenging domain of real-time systems. And what's been interesting as we work with our customers and as we see this general trend in the industry that there's a journey, and customers will take on different types of real-time cases. And what I'd like to share with you today is, as you are working on your real-time business cases, how to structure them to really best fit the kinds of business cases that you've got. So I'll share with you some of the journeys that our customers are on. And we'll talk specifically about how this relates to capturing windows of opportunity. Our best customers they're recognizing that there are moments in time where if they can identify an event and they can respond within time, they can change the outcome. And that's been a game changer for a number of customers. So let's talk a little bit around the kinds of applications that operate in real time and how you can architect in a cost-efficient manner to be able to capture those windows. First, we'll look at how to build architectures that fit those windows of opportunity. And specifically, we'll go through 3 customer cases of how they're doing that. And next, we'll look at how you can start your journey and how you can optimize on performance versus cost. Now, what I'd like you to do is just take a moment and think about, when you think about real time, what is the first thing that comes to mind? Like, what are the cases that are real-time cases to you? Now, for myself, I have opportunity to travel a little bit, and when I travel, one of the things that I'm doing is I'm using my credit card for transactions. And when I think of a real-time system, I think of every time I swipe that credit card, somewhere in the back end, analytics is done to say, hey, is this a fraudulent transaction or is this a legitimate transaction? And that needs to come back within less than a second, sometimes like just a couple of seconds, no matter where I am. So those sort of environments of an event happens, and within a second or a couple of seconds, the system needs to be able to take action to encourage the right behaviors or to prevent malicious behaviors. But these real-time systems come in all shapes and sizes. So as we look across different industries, what real-time means in one case is very different from another. So what we want to focus on is real-time is relative to the event, and it's relative to the desired response. So let's drill into this and see what that really looks like. So I live in Singapore, and I went down to the MRT, which is our subway system, and I took a picture. And what I wanted to capture was I wanted to capture all of the real-time systems that I could see and look at what happens on the back end to make all of these possible. So the first thing that happens when you go into an MRT that most people will do is they use the subway. And so to use the subway, you go through a gantry. Now, when you tap your card has a certain identification, but then it needs to go back to the underlying system and debit your account. Now, typically, these gates need to open and close very quickly, so there's about a 200 millisecond window that it needs to identify who you are, validate the card, change the backend system, update the account, and open the gate for you. So real time in that case is less than a second, say maybe 200 milliseconds. But what else is going on within that platform is you have maybe CCTV. And you can see here that there's a number of different cameras that are recording. Now, with the number of cameras that are within, say, an MRT station, there's no way that a human can possibly monitor and detect all of the events that are happening for all the video feeds. So there's a video analytics system that's running underneath these CCTV feeds that within, say, 2 seconds need to detect if an event has happened that's not appropriate. So it could be something like a zone intrusion. It could be somebody who's passed through an area going the wrong direction. It could be a crowd hotspot that is creating a safety situation. Now, all of this needs to be analyzed automatically, and the system needs to respond and alert somebody within a couple seconds. So that's a very different looking system on the back end. Well, you see this lady over here and she's on her phone. Well, there could be a mobile application that when she's in the train station can also give her an alert that says, hey, your balance, your card balance for this train system is below a certain amount, so you may want to top up before you go in. Now, this could be using something like a backend database, but it could also be using GPS for things like contextual awareness. And that system should happen within, say, a few seconds. So again, a real-time system for balance alerts, but in a slightly different time frame. If you look, you've got monitors here, and the monitors talk about real-time train positions. So it'll tell you, hey, the train's going to arrive, but the granularity for this isn't real-time to the millisecond. Maybe every 10-second update is okay. Now, it's picking up things like train position from the track sensors. So for the time that track sensor data to flow back to the system, position where the train is, estimate the time of arrival, and update. That happens several times a minute. And one more is we look at like flow detection. So flow detection could be using the GPS beacons or the Wi-Fi hotspots within that train platform. So as you walk in and your phone is polling and looking for Wi-Fi hotspots, it's giving off its location. So these Wi-Fi hotspots can pick up how many people are currently in the train platform, how many people are clustered in a certain area, if there are areas that are congested, and if they need to do something like dispatch people to help with crowd control and with helping to move some of the, improve that flow. And that could happen every couple minutes is probably okay. And the last case that we see here is the climate control. Now, a building management system traditionally has been, they'll have a schedule, and then based on time of day, they'll adjust the temperature for that area. Now, the reality is that sometimes there's this peaks of people who come in and the heat will go up, or there'll be a slow time when the temperatures will drop down. So now climate control systems can pick up this temperature data, can feed it back, and say within 5 minutes of detecting a change, can start to adjust the thermostat for the building. So now if you look across these 6 cases, you'll see that all of these to the users, right, to those business system users, all of these are considered real time. And all of them have very different types of data and shapes of data that are coming in. So let's break down a few of the cases on how this is actually pushed through the system and how the analytics are done. Let's split this into 3 categories. So the 3 categories of real-time systems. The first is massive concurrency. And massive concurrency means that a lot of people or a lot of systems are diving onto the same resources at the same time. And so the system needs to be able to manage this concurrency. So I'll share with you one of our customers, and it's a major telecom provider here in Singapore. And they're a big player within the market. They serve millions of customers here, and they do have stakes in telcos in other parts of the Asia-Pacific region. Now, one of the things that's very important for their business is making sure that their mobile customers are happy and their mobile customers continue to stay on as subscribers. So they're always looking at ways to make sure that renewal is happening, or in the terms of telco, is they're looking to limit their customer churn. A very important window for this is the moment of a renewal of a subscription. And part of that renewal is made more attractive by the offer of, say, a phone upgrade or a free phone. So, of course, this telco, when they have made these launches of, say, a new phone that's come to market, it's very important for them to make that available to all customers. Now, previously they had an iPhone 5 launch, and in the words of the customer, it hadn't really gone well, and they were just disappointed with the launch and the rollout of that iPhone launch. So they decided that they were going to do things quite differently. So they came to us, so we worked together on how to structure the rollout of iPhone 6 so that it would be a success in their eyes. So I'm going to describe to you this diagram since we're going to look at this a few times. The traditional way that people have gone after analytics problems is they start with the data they have and they try to flow it into the system through, say, storing, processing, analyzing it, consuming it, and then serving it. And then at some point they have an outcome. But actually what we find is that the most successful customers start first on the right-hand side, and they start with their desired outcomes and the insights that they need. So in the case of this telecom provider, first of all, they wanted to provision all of the iPhone 6s at the moment of launch. They had to schedule the pickup of these phones for every one of the customers, and they needed to be able to scale this up to have concurrencies of hundreds of thousands of users. So when they started to design the system, these are the outcomes, and that really guided what they were going to build in the system. So they went back and they looked at inventory. And for them, inventory means inventory of phones, and it also means the inventory of pickup slots, so times when people can go and collect the phone. They took all of that inventory data and they pushed that into Amazon's Simple Storage Service, or S3. And I'll talk a little bit more in detail later about what S3 provides. The data then flowed into Amazon DynamoDB, which is our fully managed NoSQL service. So, and I'll talk a little bit more, again, in detail of DynamoDB as we go forward. The other thing that they did was they set up the site content. So as you accessed their site through your mobile phone or through a web browser, they hosted all of the static content in S3. The second part of the system is they created a serving layer. And within the serving layer, they have load balancing, so that could handle those massive surges in demand, so the large spikiness. And inside of that, they had their web servers. And these are traditional web servers that they were using. It was also backed by Amazon Elasticache. And Elasticache is a caching service. And the role of Elasticache was, rather than having these hundreds of thousands of people diving onto NoSQL concurrently and asking, hey, is this phone available, or is this booking slot available, they put that information as counters into Elasticache. Now, when the subscribers were coming in and accessing the underlying web servers, in order to take that load off the web servers, they use Amazon Route 53, which is our DNS, so for routing, and to find the best access point. But then they use Amazon CloudFront, which is a content delivery network, or CDN. The CDN served the static content off of S3, where that site content was living, which took all of the load of serving static content away from the web servers. They only then went back to the web servers when they were executing an order for that new phone. The web server, rather than going directly down into DynamoDB, asked Elasticache, hey, is there enough inventory that's left for both the phone and for a booking slot? If it was, then it would process that order. It would go down into DynamoDB, process the order, and then it would come back with a fulfilled status. Once the fulfilled status had happened, then they would decrement the counters in Elasticache, and CloudFront at that moment, once it had confirmed the order, would then serve back to the customer and say, great, you've got your phone, you've got your booking slot, we're confirmed. Now what this looked like for the customers was that this telco was able to launch and clear all of the iPhone 6s they had in stock within 2 minutes. So actually the feedback that we got from our customer, from the telco, was the launch was smoothly, but actually the system was too fast, because everybody who was a little bit clunky on their phones, it took them some time to get through, so the stock actually cleared out a lot more quickly than we expected. So they were able to allocate all phones within 2 minutes. They were able to scale up, and they were prepared for hundreds of thousands of users concurrently. They had no phones misallocated or unallocated, which was the big improvement from the iPhone 5 launch. And management was very happy with that outcome. So the second case we'll look at, so we've looked at massive concurrency, but there's another category that's really gained a lot of interest, which is contextual awareness. Now, what this really is asking is, I want my event to understand where you are, and what time is it, and what else is happening around you. And importantly, who are you? Like, what do I know about you? So understanding all of the context around a given event. So another customer of ours is AdRoll. AdRoll is the global leader in retargeting. And for those of you who don't work in the advertising industry, retargeting is the ability to identify who a person is and then be able to give them very targeted ads no matter which website they go to, or what they'll call digital properties. So if you visited a website and you've been served a certain impression or a certain ad and you don't respond to it and you go to a different website, you may see that same ad surface again, or a very similar ad surface. And that's what retargeting is. Now, AdRoll services more than 20,000 advertisers in 100 countries, and they operate at a huge scale. So they serve more than 60 billion impressions every day, and what is pretty impressive about their business is they're able to serve these in less than 100 milliseconds regardless of where the customer is. So a very, very fast response system. They also provide a real-time bidding system for their customers, which are the advertisers. So again, we see this layout where they first started with the outcomes and insights that they desired. The number one outcome was they had to have an ad service that responded in less than 100 milliseconds. They had to create things like cross-site IDs, and they wanted to provide effective retargeting. They also needed to have, for their customers, the advertisers, they needed a self-service real-time bidding system. So they went back to the data that they had available, which is their web logs, their cookies, the bidding data, and then the actual performance metrics of the site, which in order to operate at sub-second performance levels, you had to really constantly be monitoring and assessing that data. They put all of this into Amazon Kinesis, which is our fully managed real-time streaming system service. And because of the volume of data that's coming in and the diversity of the visits on these websites, they used Kinesis in a pipeline fashion. So they take the Kinesis service, and using the Kinesis client libraries, they then pipeline that out into multiple Kinesis streams. On the backing of that, those Kinesis streams then feed into Amazon EC2, Elastic Cloud Compute, for the processing of that information and the processing of those events. Now, depending on the event, if they're serving an ad, those EC2 instances trigger DynamoDB to then serve an ad out through the ad service. Or if they have a real-time bidding system, they push the results of that analytics out into Apache HBase, which is the backing for their real-time bidding system. Now, underneath this is the real-time system as they're pushing out the ads and they're providing the bidding. But they want to always monitor and make sure that their service levels are, in that 100 millisecond range. So they capture all of the events back down into S3, and they do more analytics against that using Amazon CloudWatch and Datadog to analyze and understand the service levels, and using EC2 as the backing to be able to create better and better models for serving that data and reducing latency. Now, the outcome of this is that AdRoll, operating a very, very low margin business, it's very important for them to really be able to operate efficiently and operate well at scale. By being able to build on AWS, they were able to reduce their costs by about 83%. So cutting their fixed costs by 75% and operational costs by that 83%. They additionally are able to now they're able to operate at scale of about 2 million transactions per second when they hit peaks. So pretty high volumes for them. And because they've automated so much of this on the back end, they've moved a lot of their staffing to about 95% of their staff effort is now focused on new product development. So creating that innovation for the business. The impact for their business is that because by nature, when we visit websites, we typically, about 98% of people don't respond to an ad when they see it on the website. So they leave without converting. Retargeting allows customers a chance to see that ad again and perhaps respond to it in the future. And what AdRoll has found is that by being able to effectively retarget customers, they increase the conversion rate by about 85% or more. Now, the last case that we look at, we've looked at massive concurrency and contextual events, but now let's look at continuous feeds. And the way that we typically think of it is systems that have connected devices or have video feeds, or they have different types of sensors, maybe even looking at the larger IoT landscape. So really this idea that there's so many devices that are now pushing data constantly into the system and being able to process that and manage it. So a large customer, Dropcam, provides video monitoring hardware and software. And maybe you'd think of it more in the terms of like nanny cams. So these are little cameras that you can put in your home or you can put in your office, and they're continually monitoring the presence there. So they're taking video feeds at all times, and they're streaming it back onto the servers. Now, Dropcam is very large, so they're the largest inbound video service on the internet. They ingest more data every day per minute than YouTube does. And in fact, when we start looking at the metrics behind it, they're analyzing over 8 million activities a day, and that includes having activity recognition. And I'll talk about what that means in a moment. This translates to processing 2.5 years of video every single day. So they've expanded from just having a simple video monitoring solution for homes where people can say look on their mobile phones and see what's happening, or video monitoring in the office, to really having a full video analytics system. So this is an example of what Dropcam has been able to produce. So not just having real-time view, not just having playback, but the playback includes now things like identification of events. And if you look along that bottom histogram, and you see on there, you see the different colors, the oranges and the greens, that's when a certain zone, an event happened in a zone. So right now you'll see that there's a lady who's at a supply cabinet, maybe she's taking some goods out or she's restocking. But the fact that she's in that zone, the camera can detect that an event is happening. And over the course of the day, it can mark every time that something happened within a certain area. Now, this is all automated, and it's a complete game changer for organizations or homes that want to be able to monitor what has happened during the day, all day, across many, many different cameras. So imagine that this machine vision has enabled a completely new way of people looking at how to use video feeds. So when Dropcam wanted to take this problem and they wanted to create a much bigger offering to their customers, they first said, real-time viewing of data is okay, but what we want to offer is we want to offer them a value-add service or an upsell to a recorded data, so being able to look back in time at previous data. They also wanted to offer video analysis, so activity recognition using machine learning, and every single customer has a slightly different networking environment, so they wanted to be able to test performance and do A/B testing for, say, the compression rates or understanding which drivers should be deployed into every person's home for those cameras. So being able to really customize the networking environment for them. They started with the video feeds, so this of course is the basis of all the data that they had. They then streamed this into their own services. So they streamed this into what they call their Nexus service, and this is a pre-processing layer. So this takes the data, and it does some cleanup on the data, and it gets it into a form where it's ready for analytics. That formatted video is then stored into S3, and then a set of web services is ready for, say, the real-time streaming video. As they're going to serve that back out to the customers, they then are able to push that serve it through the web servers out across the internet. The serving layer on top of that is similar to what we saw before. So the apps come in, they contact Route 53, which gives the best access point down to CloudFront, the CDN. All static content, like the layout of the mobile app or all the static bits, are served out of S3, and only the dynamic content, only the video feed, is pushed through the web server, right? So really alleviating that load. But what about when they want to offer the machine learning, so the computer vision recording is what they call it. In order to process this data and add context and analytics to it, they use Amazon EMR, or Elastic MapReduce, which is our fully managed Hadoop service. So they push the data into EMR, they do their tagging, their analysis and their tagging of the data within Hadoop, and they store that video recording with tags back into S3 and what they call their CBR data. If a customer of one of their customers wants to go back and look at a recorded video, they now go and they query the web server. The web server looks back into, it asks DynamoDB, hey, where is this recording at? DynamoDB is able to very quickly surface out that recorded video that has tagging in, where it has all those little green and orange marks on it. So this is the architecture that they've used to be able to solve that huge challenge of ingesting 2.5 years of data every day. The impact that it's been to their business is they're now able to stream video content in milliseconds by using the cloud. And when we talked to Greg Nelson, so their VP of Software Engineering, he's said, their ability to add capacity in minutes instead of days has been really important as they've scaled their business. So DropCam now detects billions of motion events every month, and they're processing more than a petabyte of data. They have, importantly for them, they've been able to move the delivery time of a video event from 10 seconds to less than 50 milliseconds. So it's been a real change in how they could surface those real-time events out to their customers. So what about for you? These are 3 customers in 3 cases as we look at concurrency and context, and we look at continuous feeds. But how do you start architecting for your cases? What we see being the real differentiator with the customers that are able to move quickly is they start with the business requirements first. So they start with the outcomes that they want and the insights. So I'm going to take you through a journey of how to build a very cost-optimized system. So take just a moment and think, if you were to build a real-time analytics system all the way from when the data is ingested to when it's served to your customers, how much would that cost you? There tend to be very expensive systems. So I want to share with you what you could build for less than $1,000 a month, so a starter platform. So let's put some bounds around it. First, let's look at a website that has to serve thousands concurrently, that has apps and it has video streaming. Let's look at users that can have on-demand viewing of their own accounts and maybe ratings that they put up for certain content, and being able to process clickstream data that will trigger customized content for each user. The first thing that would recommend that you do to build the system is optimize the content delivery, which means offload web servers. Web servers they're great for serving some types of content, but it's really an inefficient approach and an expensive approach if you're serving static content with them. So offload as much as you can from the web servers. So as we look at these outcomes and insights, these are the 6 things that we put as outcomes, right? So serving static content, video streaming, and so on. Let's first focus on those top 3, including the monitoring. The services that you'll start with, you have Amazon CloudWatch, which is a very inexpensive way to be able to monitor the activity on your system, so measuring the API calls and being able to do analytics on that. In most cases, if we look at the scale that we're talking here, there's no cost associated because we're using the free tier. Amazon S3, what you'll see is that customers who really operate in a cost-efficient manner, they leverage S3 heavily. And S3 as an object storage offers essentially unlimited storage for you, object storage. The cost price point is pretty inexpensive. At the highest tier, it's 3 cents per gigabyte per month. And as you increase usage of this, then prices will start to drop down. So price drops after 1 terabyte and so on. For content delivery, Amazon CloudFront, so the CDN, and you can see the pricing here, about 8.5 cents per gig per month. And for traffic routing, you have Route 53. So these are really the core services for being able to take load off of your web server. So we put up, here's the same metrics that we had before. So site content, we're looking, let's say we have a site that hosts about 1 terabyte of content, have 1,000 concurrent users, maybe we're looking at 1 million monthly visits, and serving this out of US East to begin with, and 5 terabytes of monthly static download. So here's the structure, right? So this should look familiar from the previous cases. So we're using Route 53, which in this case is quite inexpensive at $1, and hosting that site content is quite reasonable at $30. The big cost that you'll see here within this environment is CloudFront, because we're putting a lot of the load onto CloudFront, but it's still only about $400 a month at these levels. Now, the next layer will be the actual hosting. So hosting these applications, we have load balancing, and we have the web application server, so using ELB and using EC2. And this is for hosting the account applications. Now, the backing for this, we'll look at using C4 instances. So maybe C4.large will be sufficient. And we're going to run these web application servers in a 2x2 configuration. So we'll run 2 of these, and we'll run across 2 availability zones to give us very high availability. And on the backing of these C4, we'll run maybe 100 gigabyte SSDs. So the price of this, you see, comes in just around $350 for that backend server. Now, when we add all of this together, we're still in about the $800 range, which for a serving layer and for the application of the web servers is still quite reasonable. Now, how can you start to really structure your application differently underneath? And this is where S3 becomes critical to building cost-optimized systems. Decouple your storage from your compute everywhere that you can. S3 is very cheap, it's highly available, and essentially for any of our business cases, it's going to be essentially unlimited in the capacity that you have available. Now, Kinesis, EMR, Redshift are all going to be critically underpinned by S3. Now, Amazon Kinesis we talked about for data streaming, and you can see the price here. I want to call out with the fully managed Hadoop, so Elastic MapReduce, EMR, there's a system underneath this called EMRFS, which is the ability to read directly from S3. If you've worked with Hadoop environments before, you would have had this restriction where you're constrained by the HDFS. So you may have 4 nodes or 16 nodes or 32 nodes or larger, but it was dependent on the amount of data you were trying to process. What EMRFS allows you to do is you store all of that data in S3, and then when you want to run Hadoop jobs, you spin up Hadoop cluster, you run that job, you store the data back into S3, and you shut down the Hadoop cluster. And it allows you to only operate your Hadoop cluster during processing time and not pay for it when you're not using it, which is a really different way to think about how to use Hadoop. The next service is our data warehousing service, which is Amazon Redshift. And Amazon Redshift is a fully parallel columnar data warehouse that it'll cost you around we see benchmarking around 1/10 of the cost of a traditional data warehouse, so about $1,000 per terabyte per year. And then we also have, launching this year, we have Amazon QuickSight, which is our BI and data visualization tool. Now, as we put these into the system, and what I've done here just to make it a little easier on the eyes is I've taken the services we've seen before and I gray those out. So let's focus on the ones that are colored in. So now we're going to be building up the behavioral modeling system, right? So this is the analytics part. We look at account transactions, say about 1 gigabyte. We have maybe 250 gigs of clickstream data that we'll ingest. We're running EMR with EMRFS. And say we run 20 hours of jobs, we do that 16 times a month, and we have maybe 4 people who are, 4 business analysts who are accessing the system. So this, we'll see here, you've got transactional data that comes in batch, and that flows directly into Amazon S3, so capturing those user actions. But we also are capturing the clickstream data, and that flows in through Amazon Kinesis and up into S3. Data that is nice and structured, so data that already has a schema, will flow from S3 into Redshift. But the data that needs some context, say clickstream data, where you're trying to map user journeys, or you're trying to map things like what has created user satisfaction, and you're looking to analyze that, that would be done in Hadoop. So the Amazon EMR runs those 16 times it's running those jobs using EMRFS, and the finished contextualized data is pushed from EMR into Redshift. Now, those 4 business analysts that are using QuickSight will then access Redshift directly and be able to do their visualization from there. So looking at the cost here, we've added on another 50 for Kinesis, another 50 for EMR, 20 for Redshift, and the others are a bit small, so QuickSight for $36. This takes our total up to $979. So this includes, at this point, the ability to serve static content, video streaming, monitoring, have users access their accounts, and have behavioral modeling for less than $1,000 a month. Now, I'm going to add on the scale layer. So as you start to really scale out to larger cases, this is where you'll be using NoDB. You'll be using NoSQL because it's very low latency for serving information and responding to key value queries. To take load off of your underlying services, you may use a caching layer, so you may have data caching. AWS Lambda is our serverless compute, and this is the ability to use event triggers to run small amounts of compute and trigger downstream events. So Lambda, again, has some pricing there. There's also the simple queuing service, which this may be the decoupling connector between two different stages of your event pipeline. So as we build this last piece around customized content, this is how those last pieces fit in. So Amazon Kinesis, there may be a clickstream event where it then triggers an Amazon Lambda function, which then moves the event down into DynamoDB. DynamoDB is then accessed through Elasticache, which then becomes the serving function out to the web server. So to take that load off of DynamoDB. Now, one thing that you'll have seen on that previous one is I didn't put the pricing in there because as you start to, for those last few services, because as you start to scale your business case, there can be very different configurations in application design. But again, it's very possible to build those in a very lean way and with a lean architecture. So what we see is that $1,000 can take you a lot farther than it ever has before. And in fact, there are ways, and if you look at the design patterns that some of our customers use and things that you can replicate, you can actually get started on your real-time journey for less than $1,000 a month. And if you want to experiment and you want to really get your first applications up and running, you also don't have to wait for any infrastructure. You can start your journey in minutes, not months. So what I'd like to close with is, how do you really start to capture your windows of opportunity? The first thing is, of course, we start with what do you need to change? Like, what is your business outcome? In order to really build the right real-time architecture, you want to measure and constrain the time window. Because real-time in people's cases can range from milliseconds to minutes, how you design the underlying system is very important that you don't over or under provision for your case. So understand what your expected latency and understand your expected concurrency. So first start with that constraint. The second is decouple, decouple, decouple. You can get the same elasticity and you can get the same cost savings as the best customers that we have by separating that compute and storage, by separating the processing from the content, using things like CloudFront that's backed by S3, using Elastic MapReduce backed by S3 with EMRFS, using Kinesis streaming into S3. You can really start to have these cost efficiencies. The third is, where possible, leverage the cloud-native services that we have and the fully managed services. So Amazon Web Services, as we've developed as a business and as we've listened to you, we've listened to our customers, we've released to market the fully managed services that have reduced the heavy lifting that the customers previously had to do. So if we have a fully managed service you can take advantage of, you don't have to build that same functionality yourself. And finally, stay current on AWS. We are launching hundreds of features and significant features and services every year, and it's more and more every year. And some of these may really materially change your ability to scale and to save money and to save time. Like for instance, the introduction of EMRFS and Kinesis Firehose and Lambda may really change what your opportunities are. So if you look at these four ways to be able to capture those windows of opportunity, this could really be a great starting point for your first real-time applications. So I'd like to thank you very much for your time, and just to recommend the way to get started on this, in addition to joining into these webinars, we do have a whole set of online labs and training. that you and others in your organization can get up. We've got instructor-led classes where if you want to come and spend time with us and maybe we have 1-day courses, 3-day courses, 5-day courses where you can really do the deep dives and have the experts, have access to the experts as you're learning. And finally, AWS certifications. So as you start to build your business and you're building your team, and you want to make sure that you've established the right levels for, say, your solution architects or your DevOps engineers, that they've got the right certifications for that. So what I'd like to do now is turn it over to you and open this up for some Q&A. Okay, so there is a question here. So first question is, we're talking about building a real-time system for handling customer feedback. Where should we start? I think if I look at this from the customers that we have that are the most successful, what they tend to do when they build a real-time system is they start with the smallest minimum viable product. So let's say that in a real-time case like you're measuring something like your customer behavior on your mobile site, and you want to make sure that you understand why people are converting or they're not converting with buying out of your shopping cart. Start with the place where you have maybe the cleanest data and you have the best access to the group that's trying to do the analytics. And as you build from the small case, what we'll typically see happen is they'll start with maybe 5 different use scenarios. They first will test the one that they know that they can validate the most quickly, and they can look at, hey, if it's a matter of, we can test things like the checkout page design, and we can see if that's really the right point. Or we can look at serving new sorts of features out through the recommendation engine and see if there's some lift from that. So I would say take all the business cases that the group would want, start with the ones that you think you have the best access to data that you can most quickly validate, and then using the same architecture patterns that we saw earlier, then you can start in very lean ways. You may be able to test this for a few $100s a month or $1,000 a month. You start to build these systems up that ultimately can then scale up if you prove your business case. Okay. I have another question here, and let's see. So another question here is, what is the advantage of Kinesis going to S3 over going directly to S3? Yeah, so that's an interesting question, and what we're finding the advantage of Kinesis, there are a few features that Kinesis will add. First of all, when you write directly into S3, you typically would have had to write an event handler or an application handler that will take that data and chunk it and write it into S3. If you want to have also that same branching of data where, let's say that some data you want to write into S3 for deeper analytics, and some of that event data you want to then stream off into an event processing engine, Kinesis allows you to then branch that same data. So you write it into multiple places. So what Kinesis adds, in addition to the real-time streaming and the ability to scale that across multiple shards, as you move into these very large concurrency cases, it also allows you to branch things conditionally into different paths, and without you having to write that on your own. Okay. Another question here is, when my company tried using streaming data before, it completely overloaded the network and it ended up being too expensive. Is there a way to control cost on data streams? Yes. So again, if I look at the customers that have figured this out, like the ones who've said we're just going to take the Twitter fire hose and we want to see what's in there, have struggled because without having an established business case, they've just overwhelmed their system with flows of data. What we find is as you start to test real-time data, and particularly when you're pulling from sensor data or you're pulling video data, this very clickstream data, this very large and fast data, I would say actually the best way to do it is you start with a fixed data set. So you listen for maybe 5 minutes or you listen for an hour, whatever data volume you can handle. And then you take that batch of data, you freeze it, and then you start doing the analytics against that, and you test your business cases. You test and see, is there actually value in this data? But if you overwhelm yourself by you try to take all the data in and you're doing your analytics, the first business case, you're doing that in real time, you're incurring a very large cost to both resources, your IT resources and your human resources to try to swim through this large volume of new data. So I'd say block it first into a testable set of data that you can run your experiments against, and once you validate that there's something in there that's meaningful, then you start to expand that, say, from an hour to 4 hours, and then you start to do that in a continuous stream, but maybe you do it from a geo-limited set of data points. So maybe only customers who are visiting from, say, the Singapore region. And then you just start to slowly scale that out bit by bit as you scale your infrastructure up. We do also have we have facilities in place for being able to use CloudWatch to measure and make sure that your systems are behaving the way that you expect. So from an infrastructure standpoint, being able to measure those metrics the same way that AdWell does to keep all their service levels in check. Let's see. We have another one here, which is what does Amazon Web Services, what does AWS offer for developing my skills in using all the services shown today? I really think that we talked a little bit around the courses. We do have online courses that I think are a good starting point. So whether you're, if you're new to AWS, Tech Essentials, the Technical Essentials is a pretty important course to start with. Before you get deeper into the big data and the real-time courses, I would recommend taking the Architecting on AWS course. I find that tends to be a pretty helpful next step. But then after you've gone through that, we do have a big data on AWS course that is it's a 3-day course, so we run that in some of the different regions. And just look to that course as a way to really dig into how to use Redshift and EMR and Kinesis and Lambda in the most efficient way. Let's see here. So I have a couple comments here around the customer examples are great and just getting better. And yeah, and I agree. I think we've got some customers in the region here and globally that are really, just setting great examples and really showing us how services can be used best. What I think is the real takeaway that we've seen from some of these is that the path to really the path to getting better and better is finding that balance between not having to buy this really big, chunky infrastructure before you get started. And as our customers get smarter and faster and more innovative, what we're seeing is these design patterns of start small and scale, start small and scale. And I think that more and more we're going to see that the customers who can do that effectively are the ones that really start to change their industries. Okay, so a question here around mid-sized companies. So for mid-sized companies that have just a few expert developers, is it appropriate to look more at a IaaS infrastructure or a platform view when they have a distributed architecture? This is a very interesting question in that the organizations that are very large have I'll say they have the luxury of having they have teams that have a lot of different skill sets on it, so they can start to distribute workload really internally, and they don't necessarily have to change how they're approaching application design. But I'll take a customer that I find pretty interesting and pretty impressive, which is Airbnb. And I think most people who are on the webinar would be familiar with Airbnb as being able to book a room in wherever you're going to travel to, and private homes, their ability to offer up their unused capacity of a room and be able to rent that out to people. So Airbnb as an organization, we look at, as consumers, we see them as this huge global operation. And they've gone from being a couple of guys who were just renting rooms in the US to now having a full global operation. Their DevOps team is just a couple of guys. And their ability to use as many managed services as possible and not write their own applications on the back end allows them to spend all of their time as much as possible on user interface and on experience and on customer service. So by using as many of the back-end services like Kinesis, like Lambda, like Redshift, they're able to really alleviate a lot of that load on the application designer. So they're down to just a few DevOps guys that build that whole back-end platform. Okay, so there's one more question here around CloudWatch. Where does CloudWatch fit into the picture? I think one of the really important parts of having a real-time system is the ability to make sure that you're meeting the service levels of the users and the service level that's really required to make sure the business case works. And we looked at some pretty interesting cases, like if you remember that first picture of the subway system, what you're looking to monitor for, say, building management system or people tapping through the gates or the video detection, all of those have very different requirements for making sure that the user of that system is satisfied. What CloudWatch allows you to do is capture all of the requests that are being made through a system and measure things like when was a request made. You can look at how long it took to execute. You can look at who has accessed the system. So from a governance standpoint and from a performance standpoint, you're able to identify where things are going as you need them to, where they're performing as you need them to, and where you have areas that have started to fall outside of that service level that you need. So by really heavily utilizing CloudWatch logs, you can drill into where you might have had bottlenecks in the process, so you can tune that down. You can tune that down to meet that 200 millisecond or meet that 1 minute or meet that 2 minute requirement that you've got. So with that, I want to thank you very much. We do have we have a number of SAs, so solution architects, who are going to help. We have a number of other questions that I'm sure will come in, and we've got an alias here, so the AWS-APAC-marketing, where any more questions that you've got, we'd love to be able to answer those and respond back to you. Thank you very much for your time. It's been great to have you here. Looking forward to seeing more of your questions, and hope to see you on future webinars. With that, thank you very much.